Hello, my name is Robin, and if you've been going through my website and stumbled upon this podcast, then you'll know that I'm a senior in the mathematics education program at Virginia Tech. This podcast today is going to talk about expressing an irrational number as a unit, as a length. And so we're going to use Geometer Sketchpad, which I already have a blank canvas up here. And we're going to want to create a unit length of 1, just for ourselves, just so we have a reference point. Note that you can make it as long or as short as you want it. And then we're going to just take a second and think about how we can maybe represent the square root of 5 as a length. What types of shapes maybe we could use to help us to express it on paper. If we consider a right triangle with side lengths 1 and 2, we can actually result in a hypotenuse with the length of square root of 5. Note that since the formula of a right triangle is a squared plus b squared equals c squared, we could get this result, where if we're given sides 1 and 2 equal 1 squared plus 2 squared equals c squared, 5 equals c squared. So that means that c must equal the square root of 5. We disregard the negative root because we're talking about distance, and distance is positive. So anyways, let's get back to our drawing. We're going to want to go to the line segment and hold it down and go out to the one that has arrows on both ends, so the line that extends indefinitely. And we're just going to plot a point on this line. We have to plot an exterior or a point on the line because we don't want to use these points because these are control points. So we're going to name that point by using the text button A. And then what we're going to do is it's called circle by center by radius construction. Plato did state that we could translate distance. So what basically we're going to do is translate this distance down here. Why would you just think about maybe why you want to do that? So anyways, we're going to select this segment and then point A, and then go to the construct menu button, and then do circle by center and radius. Alright, so now notice that we have this big circle, and look how long the radius is. It's the same length as this segment. So now we know that this is length 1. Right? So let's call this point B. And if we want to, we could actually call it 1. And let's rename this to be 0, since this is our starting point. Now, we have a length 1 here, and to create a right triangle, we need to have a right angle here. So what we're going to do is create a perpendicular line to this line right here that we have by selecting the point 0 and the line, and going to the construct menu and go perpendicular line. Notice that we have a perpendicular line here. Well, if we plot a point at this intersection of the circle and the perpendicular line, notice again what length that is, because all radii have the same length. So this is 1 that we know. We can name it. It's going to come up C, but if we double click it, you can rename it to be 1. And then we're going to go take the circle button and draw a point from 1 to 0 to give us another length here of 1, but it also gives us length 1 up here. So we know that this is length 1 and this is length 1, so this overall length must be 2. We want to name that 2. We'll have a length of 2 and a length of 1. Now what we're going to do is connect these with a segment. So go to the segment button and click 2 and go all the way down to 1. Now look at what we have. We have a right triangle right here. So how does that help us? We are given that this side length is a square root of 5, while this is side length, while this is 2, and this is 1. If you check out my next video, I will show how to show the square root of 5 on the actual number line, this line right here.